Okay, so for this chapter, we're officially going to start algebra. Okay, so we're going to take it nice and slow. We're going to make this a nice, easy, smooth transition. That's my plan. There's nothing to be super alarmed with. We're going to start small and we're going to build up chapter by chapter. Okay, so this section is all about the addition property of equality. So I do want to remind you of a couple of things. In previous sections, we talked about expressions versus equations. And ultimately, it came down to expressions have no equal sign, equations have an equal sign. Okay. Expressions could only be evaluated or simplified. But because of that equal sign with equations, that allows us to solve. We can get a solution to an equation. So this allows us to solve, to find the solution to the equation. So let's talk a little bit about that more in depth, okay? So definitions, again, an algebraic expression is the combination of numbers, variables, and operation symbols. When we were talking about algebraic expressions, I would often say it's just the sum or difference of terms, okay? That's very informal, but it's true. You're just taking terms and you're adding them and subtracting them. Remember, expressions do not have an equal sign, okay? An equation, on the other hand, is a mathematical statement where two expressions are equal. Because we have two expressions that we're saying are equals, that's why we have this equal sign with an equation. So equations do have an equal sign, which means we can solve them. Solving, this is really important. So underline this, highlight this, whatever your method of remembering and taking notes for math is. Solving is the process of isolating the variable to determine its value. Essentially, undo what has been done to the variable. This is the heart and soul of what we're going to do in this chapter. We're going to isolate the variable by undoing what has happened to it. And we're going to start really small and we're going to build up to more complicated equations. But for now, just know that you're isolating the variable. Your goal is to undo what has happened to it. And whatever value we get for the variable is the solution to the equation. Okay? So for example one, this is just short answer. We just want to make sure you really truly understand the difference between expressions and equations. So it says, list two examples of expressions. We could list examples of expressions from now until the end of the semester and never list them all. You're just listing any kind of combination of numbers, variables, and operation symbols. Just make sure you don't have an equal sign. So I could have something like 5x plus 7, x squared minus 9, 3 times x plus 4y. There are loads of different ways that we could represent an expression. Okay, just come up with two of them. Just make sure there's no equal sign. Now it says list two examples of equal signs. Let's say we take these exact same expressions. So I have 5x plus 7, but now I want that to equal 12. Now it's an equation. Okay, let's say I had x squared minus 9, and I want it to equal 0. Now it's an equation, okay? Let's say I had 3 times x plus 4y equals 2x plus 7y. Now it's an equation. One thing I do want to point out is in this class, we will only deal with equations in one variable. So at this point in this chapter, you wouldn't have something like this where you have x's and y's. You would only have x's or only have y's. So what it means is you don't have a single variable necessarily. You just have one type of variable. So only x's or only y's or only z's or whatever. Okay? So there you have it. We have more than two examples of expressions, more than two examples of equations. And for this video, I'm going to go ahead and also look at topic 2 since these are both short topics. Okay, so next up, topic 2 says determine whether a number is a solution. We've actually done this a couple of times before in previous videos, okay? So this is just another time that we can practice this. So remember, the definitions, that's important. So the definition here, the solution to an equation is the value for the variable that makes the equation true. A lot of times we'll say it's the value for the variable that satisfies the equation. So satisfies the equation just means it makes the equation true. Okay, so what's really happening is you have to think of these equations as like a scale, like a balanced scale. So you can kind of imagine those scales. They have like the little bowls or plates. We need to make sure that this scale, the left, really does equal the right. And when we get an equation, it starts out balanced. And as we undo what has happened to the variable, we need to make sure that we maintain this balance, okay? So kind of keep that in mind. When we're trying to figure out the value that satisfies their equation, we're looking for the value that makes sure the left and the right are balanced or true, that they're really equal to one another, okay? So the way we check this is we plug the value that's given to us into the equation. We simplify it. If we get a true statement, that means that number is the solution to that equation. If we don't get a true statement, that number does not satisfy the equation, which means it does not balance the equation, which means it's not the solution. Okay? So let's look at our first example. We have a really simple equation. We have 3, and then in parentheses, we have x minus 2 equals 6. We want to determine if 4 is the solution to this equation. So all I want to do is rewrite the equation. Anywhere I see an x, I want to replace it with a 4. So I get 3 times, in parentheses, x minus 6, which is 4 minus 6, equals 6. Hopefully you've had time to really practice the adding and subtracting and multiplying and dividing of integers. So here we're subtracting 2 integers. We learned in previous sections that you can always convert subtraction to addition. So I could rewrite this instead of 4 minus positive 6, I could write as 4 plus negative 6. And then you're adding 2 numbers with different signs. You subtract the absolute values. So 6 minus 4 is 2. And then I only have 4 positives, but I have 6 negatives. So that makes this -2. Now, that is the technical process. You need to really practice that to where you don't necessarily have to show this work every single time. I want to be able to say, hey, what's 4 minus 6? And you're automatically like, it's -2. So we get 3 times -2 equals 6. Now we have to multiply 3 and -2. So remember from previous sections, 3 times -2, you're multiplying 2 numbers with different signs. When you multiply different signs, you get a negative product. So what we have here is -6 and 6. Well, -6 does not equal 6, so we would say no, 4 is not the solution. Okay? And now let's just repeat that process for part B. Somehow I lost my part B. I'll fix that at some point. But it says determine if -2 is the solution to -4x minus 3 equals 5. So we're going to do the same thing. We're going to rewrite this equation. Anywhere I see an x, I'm going to replace it with a -2. So I get -4 times x, which is -2, minus 3. I need to know, does this equal 5? All right. So you have to kind of go back to that idea of the order of operations. We have, hopefully you kind of remember this, PEMDAS. So we want to look for parentheses, take care of all of those. We want to look for exponents, take care of all of those. And then you have multiplication and division, addition and subtraction. You want to take care of all multiplication and division before your subtraction or addition. So I need to take care of -4 times -2. Well, when you multiply 2 numbers that have the same sign, that just makes the result positive. So -4 times -2 is 8. I then have 8 minus 3 is 5. So now we can do that addition or subtraction. So 8 minus 3 is 5. And does 5 equal 5? Yes, absolutely. So we would say yes, -2 is the solution to the equation. Okay, so that is a quick way that you can just check to see if you really do have the solution. And that's going to be a powerful thing, especially as you're learning to solve equations. You need to know how to check your solution. Once you get really comfortable with this, you don't have to check your solution all of the time, but you do need to know that you can always check the solution if it comes to that.